An ALU in Minecraft. Oh, I can't fly. Oh. Here is my simple redstone thing. Red powered, that is a 1. See, it's a 1. And then off darker red is a 0. Okay. Simple enough. My ALU has 4 functions. It's add, subtract, multiply by 2, and divide by 2. I should have wrote that, but oh well. And I have a huge display, a 5 block display thing, which has all segments, 2 7-segment display minus this 1 segment, because I don't need it. And my ALU is fairly simple. I have an input bus where I input a number and it goes all the way down the line, and it goes to all of my functions here. So it goes to this function, and then it's outputted, and if the what is this? I forgot this. The opcode, I think. If it is on the correct one, so it's on add. If it's on the correct one, and then it will be powering. Okay, no, it will unpower a torch right here, which is connected to the AND gate. I should have went to this one. So it goes to the torch, it unpowers it, which would turn this off, so that the output, which is on, can go through, which will travel over to the binary display here, which is inverted so that it can be powered when this is powered. Oh, this one is. So it's inverted so that it can be powered when this is powered. It's very confusing. Okay, so I hit a 2. Okay, now how about we do subtraction? Well, I only put a 2. What is 2 plus 4? It is 6, and I have a 6 here. Okay, what is 2 and 1? What is 3 plus 4? 7? Okay. And we can do 3 plus 5 is 8. And there's an 8. It's very simple. Now, how about we do some subtraction, which is a lot more complicated. So the subtraction thingy here, the op code is sent through over here all the way past to the subtract. This is an adder to the subtractors here. The subtractors are just one of the inputs of an adder is inverted, and the carry in on the first adder is on, so that stays on all the time, and one of the inputs is always inverted, or is inverted. So it's just like an adder, except for it is not inverted there, or it's not powered there, and it's inverted one of the outputs or inputs. So I have the same thing happening as the adders to the subtractors. There's a torch under there, and it is being powered by that, which I got from over here. That was that opcode line thing. See, these are powered, so they're powering the torch, which is unpowered now, which turns the torch on top on, so it can't get through. But off, it turns this torch on, which will turn this torch off, which will allow the output, whatever it is, to go through. So the output is off now, it goes through, and it's off. Which one did I hit? Okay, looks like they're all off. I'm going to hit this one right there, and this one. Actually, you can't subtract a small number from a high number. At least my ALU can't. There. What is 2 minus 1? It is a 1. So there's the 2 on the top. And is this the subtractor? Yes, it is. There's the 2 on top, and so here's the 1 on bottom. The 1 goes to the first subtractor, and it goes to the inverted one because it is going to be the lower number, not that is subtracted. No. The higher number is subtracted from the lower number. So this one goes to the right, which is not inverted, and the lower number goes to the left, which is inverted. Then it's very confusing. And then it goes through the adder. In reality, it's this is 1 and 1, which makes it go to the 2, which is over here. And since it's already powered, it goes to the next one. And since they're all powered, it goes over to the next one and next one and next one until it's over here, which is, oh no, this is wrong. What? Is this an adder? Oh yeah, I see. No, wait, what? This is the adder. Okay. There, so this would be the carry out right here. But since it is an adder, you don't carry the out. No, it's a subtractor. You don't carry the out to the output like the other one, because the number would be too high. So you just get rid of the carry out. And that is kind of how an adder works, kind of, I think. Now this is shifting. So we have 4 bits here, and we have the 8th bit carried over into the 16th bit. See, 16, 8, 4, 2, and 1. That is my multiplier. It says shifting right, but that's wrong. It's supposed to be shifting left. Yes, it's supposed to be shifting left for it to multiply times 2. And then it has the same AND gate. So this is on because the opcode is not selected for the multiplier. And then shifting left, oh no, shifting right is dividing. So it is this one, the far 8, so it's shifted to the right. Oh no, dang, it's shifted to the left. Okay, so you divide 8 by 2, it goes to the 4th one. So this is 16, 8, 4. 2 and 1. So the 8 divided by 2 would be the 4, and the 4 divided by 2 would be the 2, and the 2, this is just complicated, 2 divided by a 2 is the 1. Now this is the trouble I had. The 1 divided by 2 equals 1/2, but I don't know how to make a 1/2 or 0.5, so I just left that out. Doesn't matter too much, I guess. And that's how my multiplier and divider works. Chicken, you're my friend. I am subtracting. Okay, so what is 8? What is 10 minus 5? 10 minus 5 is 5. 5, okay. And so what is 6 minus 5? 1. 1, okay. Now what is 8 minus 7? 4, 5, 6, 7. It is 1. Okay, what is 8, 9, 10, 11, 12, 13, 14, 15 minus 0? 14, 15 minus 0 is 15. Minus 1 equals 14. How about we do 15 minus an 8? 7. Oop, is 15 minus... Yes, it is. See, sometimes it's smarter than me. There you go. Okay, now how about we do multiply? So, what is 8 times 2? I do not use these because it's automatically timesing by 2 or shifting to the left. So, see, 1, 2, 3, 4. 1, 2, 3, 4. And that's the 5th one. So the 8 is shifted to the left once, which is the 5th one, which is 16, which is displayed as 16 up there. So 8 times 2 is 16. This also works. 8 plus 2 is 10. 10 times 2 is 20. 16 and 4 is 20. 20. Now I can keep going. 8, 14, 15 times 2 equals 30. There's a 28, 20, 30. That is 330. You see how I don't have to use this one? A 2 is like that, and a 1 is these two. So the 3 doesn't use it either, so I don't even make it. It wouldn't be too hard to make. I could just slide it in right here, I guess. Yeah, I could. Who knows, maybe I'll make it much larger. Ooh, I don't think I have enough space actually. I would have to make it 2 layers. Nah, I probably won't. The decoder for this, so that I don't have to select 4 different opcodes for 4 different things. I just have 2 levers here. Is this back here. It's pretty simple. So it's 0, 0, which turns these 2 on. So this is powered, which is inverted, so it's off, so it does nothing. And then we go to the next one. Since this is unpowered, this torch is powered, which turns off, which powers this block, which will turn off this torch, which does nothing as of now. And then this is off, so it turns this torch on, which powers this. Then we go to the next one. This one is on because this block is off, and it powers this block here, which turns this torch off and does the opposite. And then so here we have this torch being, this block being unpowered, which the torch is on, does the block thingy, yes. Same thing as this one. They're both on, which makes them off, which powers the block and makes it off. So the top is off, which is inverted into it being on, which will travel over to the dividers and gate, which is very simple. I inverted it so that it would go. I don't need this one here actually. Why did I need that block there? I did not need that block there at all. Maybe. I think I did. I do think I did. Yes, I did. Okay. What was I doing? It's inverted to here, yes. Which turns off the torch, one of the torches to the AND gate, and so I broke that. the output can be put out. So it's on, the output is on, it's off, the output is off. And that's a simple way to control the outputs. Dang, I broke that again. There you go. And all fixed. And that is going to each of the AND gates. And then from the AND gates, it's just shifted left or right for division or multiplication by 2. You could shift it again, double shifting it to make this is the 4. You can make this 4 times 4 would be 16. So you could shift it 2 and stop it there, which would be 4 times 4. And you could do 8 times 4, which would be the next bit, which would be this one here, which would be 32. 8 times 4 is 32. And that is the simple way of multiplying and dividing by even numbers. The odd numbers, I can't really figure out too good. I've did some research, I tried figuring it out, but it's pretty complicated. And I guess that is my whole ALU. This decoder here, it's 2-bit decoder. It decodes 2 bits into all 4 numbers, so you can get 4 numbers out of 2 bits. 0 and 0 is 1 number, 0, 1 is, okay, that would be 0, that would be 1, that would be 2, and that would be 3. That's 4 numbers. So, you get all 4 numbers from 2 bits. And from 5 bits, you get 30 numbers. It should really be 32 numbers, I think. Yes, it should be 32 numbers. But my ALU does not use 32 numbers. If I add all of them, add 8 and 8, oop, that's off. Oh, 4. Okay, so what is 8 and 10, 14, 15 plus 15? It is 30. Because an adder is not supposed to have another 1. When you add 1 plus 1, you're going to get an even number, which is 2. So you can't just have one random 1 like on top. They would have to be the same for it to be an ALU. And if you don't know what an ALU is, it's an arithmetic logic unit. It has opcodes for what you want to do, which is these right here. And it uses the same inputs and it goes to the same output. But it does different functions according to the opcode. And that is basically what an ALU is. You don't need a display here. I just put it there because I thought it'd be cool. This is the for the output. This is for this. For the numeric display. There should be 30 lines here. 1, 2, 3, 4, 5. I'm not gonna count them all. I know it's 30. I made it. Each one is encoded. This is a binary encoder here. When it has a line on top and torches powering on the bottom. It goes to each separate segment, obviously. Most people know this. And it powers each separate segment. So, the middle segment here is right here. If I just follow this line down, this is a little confusing because of the way I made it. So this is on, which turns this torch off, which powers this block here. So if this torch was on, it would power this block, which would turn this line on. So it goes further down into another inverter. I just did that because the signal wouldn't reach all the way up. So if I follow this down, all of these torches here would power this middle segment. And that is my display, my numeric display. The binary display is simple. Okay. So, this is the output bus. It's where the output of the functions are traveled to. So, let's do an add. Okay, let's do this one because it's closest. 8 plus 8 should be the second one. 8 plus 8, which travels just down there. And then it goes back up. So 8 plus an 8 would be correct. It's not 8, it is 16. So it is carried out to the carry out. And that is sent over to the through the thing, which says if the opcode says it's allowed, if it's adding, then it'll go through. And so it goes to the binary thingy here, which is inverted. So this is on, so it inverts it to be off, which allows this torch to be on. And it is also sent back over here, like I said a bunch of times, to the right code, which is, there should be a torch like this on the side of each block, except for this one, so that it would just unpower just like that. So that's what I'm looking for. I'm looking for just one all the way here. And it looks like there's some down there. So I'm just going to fly over. Next, and oh, this one is off, so it must be this one. So this torch is off, this torch is off, this torch is off, this torch is off, and this one's off. So nothing is powering it on top, and all the rest are powered. And that is the display of my ALU. And I guess that is the whole video. And yes, top minus the bottom. That's the subtractor. If you subtract like 8 minus 4, you get some weird number, because you'd get a negative 4, but here it says 12, which you know is not right. It's negative 4. That is something I had trouble trying to figure out as well. But other than that, it's okay. And I guess that is everything. Thank you for watching. Bye. Okay, one more thing. An ALU, all it needs to be is an adder and a subtractor. It doesn't need to multiply and divide. The most simplest ALUs could just add, not, or XOR. They don't even need to add or subtract. But all an ALU needs is two functions with the same input and the same output. And that is all. Bye. One more thing. Oh, move this a little closer. One more thing. Okay, you know what? Just start over. Okay, one more thing. I forgot. God dang it. Hola.
Where is everybody?
Working, probably.
No, there are cars around here.
Oh. Back. Oh, yeah, watching a movie.
It's not barbecue.
Oh, yeah, me too.